Hello everyone. In this video, we are going to learn the derivation of electric field due to infinitely line charge wire. Okay, using Gauss law. Application of Gauss law also we can say. So you can see electric field due to infinitely long straight uniformly charged wire. Okay, you can see this is a wire. Okay, line charge wire. Q charge is there, which is uniformly spread. Okay, and lambda is what linear charge density. What is lambda? Linear charge density, charge acting per unit length. This is what linear charge density. So I want to know the electric field at a point P, which is a distance r from the wire. So to know the electric field, okay, consider a Gaussian surface. How will the Gauss? Suppose this is the line charge wire. Okay, infinitely length. Length is what? Infinite. Both sides it can be extended. Now to find the electric field at this point P, which is a distance r. So I have assumed one cylindrical Gaussian surface, okay, passing through the point P. Okay, so this is a cylindrical Gaussian surface. So there will be three surfaces, right? Surface here, up surface should be there. Here, one surface will be there. Another surface which will be surrounding the line charge wire. Yes or no? Now, the direction of electric field is what? In this direction, it will be radially outward, as you know. So let a point P at a distance r from the wire. To find the electric field at a point P, imagine a cylindrical Gaussian surface, which I told you. You have to find the electric field at this point P. So for that, we have to assume a Gaussian surface, which is cylindrical. Now let's do the derivation. Okay. So what we have? We are having. You can see this is the wire. Okay, which is infinitely charged. So we have assumed this is infinitely charged. So no? We have assumed a Gaussian surface which is cylindrical. Yes or no? At distance what r, one point P is there. Okay. Electric field will be in which direction? In this direction. See, this surface 1 is there, surface 2 is there, surface 3 is there. See, electric field is in this direction, but area vector is what? In this direction. So at 1 and 2 you see. Okay, theta is what? 90 degree. Okay, so what is the flux formula? Flux is what? E into ds into cos theta. Okay, so flux through surface 1 and 2 will be 0. Do you agree with me? Why? Because cos of this is cos theta. Okay, this is a cos theta. Okay, flux formula is there. Flux is what? E ds cos theta. As the theta is 90 degree, so flux through one surface is equal to flux through second surface, that is equal to 0. So we will have the flux through only surface 3. Okay, fine. That is the lateral surface area of the cylinder. Yes or no? So first we consider a small area of ds. So we want to know the small amount of flux which is passing through this point. Okay, so small amount of flux d phi is what? E into ds. Okay, in this case electric field is in this direction and area vector is also in same direction. So theta is what? 0 degree. So cos 0 is what? 1. So cos of 0 we can write. So what is the d phi? D phi is equal to what? E into ds. So this is the small amount of flux through the small area ds. To know the total amount of flux, we have to integrate. Total flux is equal to what? Integration of d phi, that is integration of E into ds. Okay, so what we can write? E is constant, so integration of ds. Okay, what is the surface area of a cylinder? Okay, let's take the length of the wire is L. Okay, so surface area of a cylinder is what? 2 pi RL. Okay, now so we can write E into 2 pi R into L. This is the curved surface area of a cylinder, this part. Okay, this area of this, okay, curved lateral surface area we can say, that is what? 2 pi RL. Let's take equation 1. Yes or no? Now we also know that from Gauss law, okay, by Gauss law, what we learned? Total flux through this surface, okay, is equal to what? Q by epsilon naught times enclosed by the surface. Like 1 by epsilon times the charge enclosed by the surface. Let's take equation 2. So this flux and this flux will be same. Yes or no? So we can write 1 is equal to 2. You can do quoting 1 and 2. What we can write? E into 2 pi RL is equal to Q by epsilon naught. Yes or no? Okay, what we can write E is equal, implies that E is equal to what? 1 by 2 pi RL into Q by epsilon naught. Okay, as we know that lambda is the linear charge density. So lambda is equal to what? Charge acting per unit length. So from here what we can write, what is the charge value? Q is equal to what? Lambda into L. So substitute the value of Q here. So we will get E is equal to what? Lambda L upon 2 pi R L into epsilon naught. So you can see L get cancelled. Okay, so what we are getting, E is equal to what? 1 upon 2 pi epsilon naught, yes or no? Lambda by R. If you want to write in the form of 1 by 4 pi epsilon naught, what we can do? We can multiply by 2 and divide it by 2. So we will get E is equal to what? 2 lambda by 4 pi epsilon naught into R. Okay, or in short we can write E is equal to 1 by 4 pi epsilon naught is what? K. So we can write 2K lambda by R. So this is the derivation of electric field due to long infinitely charged wire. From here what we learned, what we see, electric field is inversely proportional to the distance. Okay, so as you move away from the wire, okay, graph will be like this. Electric field versus R. Okay, it is inversely proportional. Okay, this is the derivation. I hope you understood. Please just share this video with your friends. Okay, subscribe the channel. Thank you.